Welcome to a new Voltlog. Today we'll be taking a look at this digital microscope that was sent in for the purpose of this review from Andonstar. If you've been a subscriber of the channel for the past couple of years or so, then you must have noticed my other microscope, the trinocular digital microscope. I've been using this one occasionally when I need to solder some very small components, do some repairs. I'm talking stuff that's usually smaller than 0402. So in this video I will be providing a comparison between something like this trinocular microscope and a digital camera monitor microscope for the electronics workbench to help you make an informed decision whether to get one or the other. Unit was delivered to me from an Amazon warehouse in the EU, so that's really fast shipping and no customs involved, but I hear they can also ship from US warehouses or directly from China. It's nicely packed with protective foam, and inside you get all of the accessories required to operate this microscope system. Putting everything together is really quite straightforward, no user manual needed for that. There's just two screws to attach the vertical post to the metal base, and then the monitor camera assembly just slides into its holder and is secured using a couple of thumb screws which have some rubber stoppers on the end to prevent scratching. Build quality is good, but nothing to write home about. For example, the mechanism for sliding up and down, it works, it does the job, but it's not smooth in any way. You also have the option of tilting this to the back to get a different angle on the working surface, but for general use you'll probably want to keep it vertical. I like the fact that they have tried to optimize the wiring, so you get this combo power cable which feeds power to the LED lights at the base and to the camera/monitor system at the same time, because it splits from this remote which controls the turning on or off the LED lights and adjusting their brightness. They also include one extra USB cable, and I guess this can be used to connect the microscope to a computer. It does come with a Windows app, but I'll talk about that later. I don't like the fact that the connector on the monitor is a micro USB connector. I think all products sold in 2022 should feature a USB Type-C connector. In my view, there is no excuse for anything other than that, especially since it only adds maybe 50 cents of extra BOM cost to do that. But before I continue with the review, let me mention the sponsor of this video, PCBWay.com, which is a professional PCB manufacturer with fast turnaround times and excellent quality. But not only that, they can also help with general manufacturing like PCB assembly, CNC milling, 3D printing, so you can get your product completely manufactured with them. Check out their website linked below. The first thing that you'll want to do upon powering up the unit is to adjust the height of the camera from the stand until you get it reasonably in focus. Then you'll need to adjust the actual focus, which is on the camera unit itself, until you get a clear image. And once you have this adjusted perfectly, you will be greeted with this excellent high quality, high brightness, crisp image. And I don't think I mentioned this, but this particular model has a 10.1 inch monitor with a resolution of 1280 by 800 pixels, which is not quite full HD, but definitely looks very good on this size of monitor. The camera system, on the other hand, is 4 megapixels, so that's about twice the full HD resolution, so you can capture some really high quality images and videos in high frame rate at the same time. There is also the option of using an external monitor via the HDMI port. I don't know if it will output the full camera resolution over HDMI, but be aware that you will lose the built-in monitor image when using the external HDMI output, and you will also lose the ability to record videos. So that feature doesn't really make a lot of sense unless you've got like a damaged, cracked built-in screen, because otherwise why would you get a microscope with a built-in monitor if you plan to use it with an external monitor? At that point you would just get the camera itself. The camera includes by default a UV filter add-on, which is very useful for protecting the actual lens of the camera from scratches, dust, and general fumes deposition if you're doing soldering, for example. It's much cheaper to replace the UV filter when it's done, and they claim the magnification for the entire lens system and camera is up to 300x, which is way more than you need for general electronics work. So the image looks very good on this, but let's talk about working distance, because that's something you're going to care about if you do soldering. You need space between your working surface and the microscope lens to do your actual soldering, and with this microscope the working distance is just around 7 to 8 centimeters or 2.5 inches. It's not great, but not terrible either. You can probably do some soldering, but there is a good chance that you're going to be hitting the lens with the soldering iron. By contrast, with my big trinocular microscope, I have at least double that distance, which makes working under it much nicer. However, here is a neat little trick that the user manual doesn't mention. So by default, you install the camera like this, inserted all the way down. You can't have it clamped anywhere in this section, because this is the grip of the zoom adjustment. You need to have it, you need to have that free to rotate the adjustment. However, you can slide the camera all the way up and grip it by the end of the lens where the UV filter is screwed in. And by doing this, you now get a much higher working distance, which gets you pretty much the 15 centimeters that you get with a trinocular microscope. So they're now pretty much equal in that regard. And this trick does not only increase your working distance, but also the usable image size. So before we were only able to capture portions of this chip, while now we have it fully enclosed in the image, plus its surrounding area. Now let's talk about the included remote control. By comparing it with the remote control I have for the camera on my trinocular microscope, this one is not as nice. It's got like really mushy buttons that don't really trigger that well, so I often find myself pressing a button 2 or 3 times just to register that function. I've also noticed that you really need to have it pointed at the sensor on the monitor for correct operation, so it could use some increased TX power on the remote, or maybe increased sensitivity on the receiver side. But I do appreciate the fact that they include a remote, because when you want to capture an image or video, you don't want to be doing that from the buttons on the monitor itself, because you have these controls, but what can happen is that you wiggle or bump the camera and mess up the image while doing that. So having a remote control is a nice feature. Also, the remote does not include batteries, so you will need to provide a couple of AAA batteries to get this working. For image or video recording, you have to provide your own micro SD card, and I believe they mentioned they only support up to 32 gigabytes. The card has to be inserted on the back of the monitor, and then you can just start capturing images or videos using the shortcuts on the remote control. There is also a built-in menu which you can navigate through using either the controls on the monitor or the remote control, and you can adjust settings like the date and time. You can format the SD card, you can turn on or off grid lines, you can change the camera resolution and frame rate, adjust brightness, contrast, all of the usual camera adjustments. But one of the functions that I'm eager to try is this Wi-Fi option that I see listed in the on-screen menu and also in the user manual, but they do mention this is still under development. It's considered an experimental feature, but what it means is that it has a Wi-Fi connection, which you can use to connect to their mobile app available for both iOS and Android. So let's give that a try. I have the app installed. You enable the Wi-Fi function on the camera through the menu system, and from this moment on, the monitor or the camera will create its own access point, which you need to connect using the settings displayed here. So you connect to that with your smartphone, and then within the app you just click the add icon and it should automatically discover the camera. And what you get is like a live feed of the camera. This is a lower quality feed with probably like half a second of delay, and you also get access to some camera settings, but it just looks like that section is not fully implemented yet, so you would only be able to use this as a secondary screen and maybe like a way of downloading captured images and videos from the SD card directly to your smartphone, which for me personally can be useful if I want to include those captured images in my YouTube videos. but I could just as well remove the SD card and copy the data that way. There is also a PC software option for this microscope, but I won't be going into that for this video. I personally don't have a use for that kind of software for my kind of usage. I don't keep my microscope hooked up to a computer. I do just PCB inspection and rework, but it does include the usual like image analysis and measurement stuff that you would expect from that kind of software. And one thing to keep in mind is that it is Windows only. So now it's time to start my final conclusion on this microscope setup. And the question is if I would recommend something like this. Well, I would start by mentioning some of the key differences that you should expect between this and a full trinocular microscope. Like a full trinocular microscope like I have here on the left is going to be more expensive, heavier, is going to take up a lot more space on your workbench, and it's going to come with its own mess of wires that you'll need to manage because it needs separate power for the camera, separate power for the lights, separate power for the monitor, plus HDMI wire between camera and monitor. And by the way, I have a video coming up on that subject where I will be simplifying the wiring of this microscope to use a single power adapter. But the bottom line is it's bigger, heavier, more expensive package, which depending on the size of your workbench could occupy as much as half of your available real estate. Now something like the Andonstar AD409 will be cheaper. It weighs around 1.3 kilograms, so you can easily pick this up with one hand and move it around. It takes up much less space on your workbench. It needs just a single USB cable for power, so much better cable management. The monitor and camera are built in, so no messing around with an HDMI cable for those. It's just a more ergonomic package. However, all of this does have implication on the performance of the two very different units. A trinocular microscope with a good camera will provide a better stereoscopic image to the operator, while at the same time capturing images with the third optical port, making the job of soldering or inspection much easier. It's going to be much more comfortable for the eye. You will be getting that sense of depth, which is something you're not getting with a simple monocular camera plus monitor setup. Also, a trinocular microscope plus camera combo like I have here will give you slightly better working distance and much better like overall image work area. Like here is the two images for comparison, and I can almost see the entire PCB on the trinocular microscope versus just a small section around the microcontroller on the Andonstar microscope. So can I recommend you get the Andonstar? Absolutely. As long as you are aware of its limitations, this is a very good tool, and I think I will be switching to this as my bench microscope because it will allow me to clear up a lot of space on my workbench. I will still be keeping my trinocular for when I need to spend long hours reworking, repairing something, but for day-to-day jobs where I quickly need to solder a small jumper wire, a small capacitor, replace a chip, something that takes under 30 minutes, I can do that just fine on the Andonstar, all while having more bench surface area available for other things, and that's a big plus for me. I can even just not keep it on the workbench at all. I can just store it somewhere. I can just take it out of storage and have it powered on and ready to run in a couple of minutes. So that's a big plus for me. Now, on the other hand, if your day job is to repair or rework PCBs, then you probably want to be working through a stereoscopic eyepiece to get that sense of depth. But if you're only occasionally doing this kind of work, which is my case, then the Andonstar is a perfect choice, and I highly recommend it because of how ergonomic the whole package is. This is just one of their models, but they have a wide range of models, even with like smaller 7 or 5 inch monitors. They even have like different camera resolutions. I feel like this 10-inch model is a perfect choice. Maybe the 7-inch would work too if you're on a very tight budget, but you can get just so much more out of this 10-inch monitor, so I would go for this if budget allows it. I would also recommend getting one of these small and thin silicone mats that you can cut to size and install it here to protect the work surface, or just avoid having a metal work surface that could short stuff the electronics that you're working on. And I will be providing a link to this in the description below, together with links where you can order the Andonstar microscope. Same as usual, I would appreciate your feedback in the comments below. Tell me if you're using something like this on your workbench and if you're happy with the results you're getting. leave a comment. Thank you for watching, and I'll be seeing you next time.